So for this problem, we're going to find intervals on which f of x is equal to x plus sine x is concave up or down, points of inflection, critical points, and local max or min for the intervals 0 to 2 pi. Okay, so this looks like a handful, right? We got a lot on our plate here, except for basically is if we just take our function and we keep going along through both the first derivative and the second derivative, we can pick up all of these things for our answer, right? So let's look at our original function. So our f of x is equal to x plus sine x. Okay, so the first thing, we're mainly going to focus on the second derivative, okay, but what we have to do first is go through that first derivative. So f prime of x is equal to 1 and then plus, and we have a cosine x, okay? And here, actually, to find our critical points, we want to find where this is either undefined or equal to 0, so we have to set this equal to 0. So our cosine x is going to equal -1, and that happens when our x is equal to pi. So this is our critical point. Okay, so we found one of our things already, critical point. Okay, so we only have one here, so we'll just keep this in mind. And now what we can do is apply the second derivative test in order to see whether this is a local maximum or minimum, right? So if we take the second derivative, we get f double prime of x is equal to, the 1 goes away, then we have our derivative of cosine is negative sine, okay? So if we plug in that pi in our critical point in here for the second derivative test, we get negative sine pi, which is equal to 0. So that means that the second derivative test is inconclusive. And that means that we are going to be redirected back to the first derivative test. So we have to do the first derivative test, okay? So let's do that one on the next slide. So we already know that x is equal to pi, that's our critical point, and our f prime of x, that is, f prime of x, is equal to 1 plus cosine x, okay? So now we're going to do the first derivative test, so sign analysis for our first derivative here, f prime of x. So I planted our critical point, and then let's pick a point within our interval, remember, so 0 to 2 pi. So we have to pick points on either side. Okay, so what we're going to do, so let's say I pick pi over 2, okay, and then 3 pi over 2, okay. So let's plug those in and see what we get. So f prime of pi over 2, that test point, is going to be 1 plus cosine pi over 2, and that's going to be just a positive 1, right? So we have a plus sign there, okay, and then for the other point, our other test point, we're going to plug in that 3 pi over 2 here. So then we get 1 plus cosine 3 pi over 2, and this again is 0, so we just get a positive 1. So this is also positive. So if we look at this, what does this tell us? At pi, which is our critical point, our first derivative does not change signs. Okay, so that means our function goes from increasing to increasing, right? So it goes increasing, it kind of levels off where our first derivative is equal to 0, but then it keeps increasing, right? So that means we do not have, there are no local extrema here, okay? So neither max nor min, max nor minimum, okay? So that answers our second, or like the last part of our problem, right? So it's neither a maximum nor a minimum. Okay, so now we have to find the intervals on which our function is concave up or down and points of inflection. So that means we're dealing with the second derivative. All right, and our second derivative is equal to negative sine x, okay? So where does this, the second derivative equal 0? That would be when sine x is equal to 0, and that is at the point x is equal to 0 and pi on the interval. And if we said 2 pi, that would just be repeating 0, right? So we just say these 2 points, and we'll go from there. So now we're going to do a sign analysis for our second derivative. So if we plant our critical points, we have 0 here and pi here. We can't go to the left of 0 because that's the end of our interval, and we can't go further than 2 pi to the right hand side, okay? So now if we plug our test points, we pick those. So again, I'm going to pick the pi over 2 and 3 pi over 2 because they're pretty easy, right? So now what we're going to do is plug in these values, the pi over 2 and the 3 pi over 2, back into our original f double prime of x. So for the first point, we have f double prime of pi over 2. Okay, so that's going to be negative sine pi over 2, so a negative 1. So that's a negative value, so we have a negative sign there. And then if we plug in the 3 pi over 2, our other test point, we get negative sine 3 pi over 2. So that would be a negative 1, so that'll turn out to be a positive 1. Okay? So that's that. And then we see here how at pi, at our critical point, our f double prime, our second derivative, changes from from negative to positive. So it changes sign, so that means we do have a point of inflection at pi. Okay? So what we can write is, so we have a point of inflection at x equals pi. Okay? And so for as far as our intervals of concavity, so concave up, so we're going to look for this one here, the positive one. So that would be from pi up to 2 pi. Okay? And then our concave down on the other one, on the negative one. So that would be from 0 up to pi. Okay? So let's write all of the conclusions on the next slide. So, so first of all, it was asking for intervals of concavity. So we have concave up, like I just wrote on the last slide. So concave up on pi to 2 pi. That's our interval. And then we have that we found concave down, where the second derivative is negative on 0 to pi. Okay, so that answers the first part. Then we had where are our points of inflection. So then points of inflection, because the sign of our second derivative changed at point singular, right? Because we only have one point at x equals pi. And then we had where are critical points. So critical point, this is where our first derivative was either equal to 0 or does not exist. So in our case, it was because the f prime was equal to 0. Critical point at x equals pi, but we can write no local extrema there, right? Because our first derivative did not change signs at all. So, but no local extrema at x equals pi. Okay, so that's basically it. Those are all of the conclusions that fulfills the answer for our problem. Okay, so that does it for this video on the shape of a graph. I hope that helps, and good luck studying.